Hi there, welcome to my New Zealand Scholarship Calculus class today. Today we are going to look at 2015 question number 2b. It says a car is traveling at night along a road shaped like a parabola with its vertex at the origin. The car starts at a point 100 meter west and 100 meter north of the origin. There is a statue located 100 meter east and 50 meter north of the origin. It's a story given. A car is traveling in a parabola shaped road, and there is a starting point given, and there is a statue on the side of the road. So the question is, at what point on the road will the car's headlights illuminate the statue? If the car is traveling at night, so there's a headlight going straight forward on to the car. So we need to find out at what point the car can illuminate the statue. So first we need to draw a picture to understand how this car is traveling. So basically it's given that the car is traveling on a parabola. So let's draw parabola, and there's a vertex at the origin, and also car start at 100 meter west and 100 meter north of the origin. So basically if you visualize a parabola, so we can see a parabola like that, but in this case parabola is like this because we look at the coordinates, say x and y coordinate, say. So the point of start, actually the point 100 meter west, if you take west, north, south, east, so west 100 meter west and 100 meter north, that means up here. So that means the point of starting, the point of the car starts at 100 meter west and 100 meter north, and it's going through a parabola. So that means it's not a parabola like this then. So it's a parabola going like this. So it's going through it like that and like this. So it's a, first we need to visualize how the car is traveling. So the car is traveling on a parabola road shaped like a parabola, and vertex at the origin here, so 0, 0, 0 point here, and then there's a statue located 100 meter east and 50 meter north. So 100 meter east somewhere here and 50 meter north, so, okay, somewhere there. This point is 100, 50, this point. So now this is a statue, point of the statue, it's a statue there. So now we are asking, so the car is traveling, so the car is traveling like that, so it's traveling like that, so car goes up, and then what will happen is that if the car comes somewhere here, that will reflect it, the headlights towards the statue. The statue get illuminated. So that's the point that we need to find out. At what point on the parabola that this car, actually say let's see, this point is A, so we need to find out the coordinate of A, and then let's see, this point is P, let's see, this is the P point, so we get another point Q here. So the coordinate of the point Q is to be found. That means the value of the x value is A and y value will be depending on the equation of the parabola. So we can write the equation of the parabola in this particular case. Let's start with the equation of parabola. It's a equation going this way, so that means y squared is equal to kx. It should be y is equal to kx squared because the parabola is going this way. It's not y squared equal to kx. Y squared to kx is like this, y equal to kx squared. That means if you put two values of x, you get the same y. So that means if you put 100 or minus 100, in this case actually it's minus 100 in the x-axis, minus 100 because it's the negative side. So if you put minus 100 or plus 100, you should get the same y value. So this is the parabola, shape of the parabola should be looking upwards. Okay, y equal to kx squared, not y squared equals kx. So y squared equals kx is the parabola going this way. So pardon about my first mistake, it should be y equal to kx squared. Okay, now we need to find out what can be the equation of this line. Basically we need to find out the equation of this line to find out the gradient, so we can actually find the value of a. So I'm going to give some hints. I'm not going to completely solve this question. Let's see how we are going to tackle this question. First you need to find out the gradient along the line. So if you have a parabola like this, what is the gradient? It's a dy by dx, so which is equal to 2kx. So that is what the first point of the first equation of the parabola, the gradient of this curve, this line, that will reflect the light, because when the car going at this point, the gradient or the tangent to the q is equal to have a gradient of dy by dx. And then we also know the point 100 is in the 100 and 100 is on the line on the parabola. That means 100 is our y-axis, which is equal to k, x equal to 100, so minus 100 squared actually, so which gives me value of k is equal to 1 over 100, which is equal to 0.01. so we know the value of the parabola, the constant k of the parabola now 0.01, and also we know the gradient of the point here. So therefore we can write the equation of qs. The value may be equation of qs. At this point there's a tangent going that way, so which can be equal to y minus, if you have the coordinate of this point y1 equal to m, the gradient is now found, dy by dx equal to 2 over, because the gradient at this point is dy by dx 2kx, we can find 2kx. 2k is equal to 2 over 100. X is the point at that point, so x is the coordinate of this point at x1, so x minus x1. So it's a equation that you should simplify. Now I'm not going to simplify it fully, so now I'm going to visualize it like, if you know x1, so x1 coordinate is now a, we took it as a, so because this is the coordinate of a, so you just put a, and then we can find y1, because y1 is again coming from the parabola equation. So if you know x1 for this particular case is a, and then therefore y1 is equal to kx squared, ka squared, so k is equal to 0.01 a squared. So we have some points now to simplify this guy here. So once you get the coordinates correctly, so you substituted this equation, and then you get an equation for this line. So once the line, since this line passes through s, because once you get the equation of this line, and since it passes through s, which is equal to 100, 50, so you substitute in here, so you can find out the value of a can be found. So once that means a is the coordinate, because what point on the road will the car's headlights illuminate the statue? So if you substitute the values in the first equation and then find the value of a, so you can find the value of a. So I will give the answer to the value of a should be 29.29. So you get a value of 29.29 for a, and then the x coordinate is that, the y coordinate is the height of that. Basically you substitute it in this equation, so we can find the value of k, which will be, this is the point q, the point q equal to 29.29, the value of 8.58 meters. So both are meters, so this should be your final answer. So I just gave a rough idea. So what you need to do here is that please take a piece of paper and try to visualize this question. So this question is an interesting question where a car is traveling on a parabolic path, and at the beginning you might wonder how to draw this picture, isn't it? Because it doesn't give you a clue how to draw a parabola. Now parabola can be this way, so I also made the same mistake. So you can start with the thinking that, okay, if the cars to be start at west minus 100, west is 100, actually should be minus 100, in this case it's a meter, 100 meters left and 100 meters right, the other point. So you put that point here, the starting point of the car, and then it has to travel on a parabola, and then it towards the origin. So vertex is at the origin, so it comes down here and then go past the point origin and go upward. So when you go upward, so then the headlights will flash towards the statue. The definition of headlights flashing towards the statue is what? Is the tangent at that point. So we need to find the coordinate of the tangent, coordinate the point where the tangent at this point go along the point S, the statue. So that's why we found the tangent here. This is the tangent. So if the tangent passes through the statue, that means if you can find the value of the tangent in terms of A, because there's only one unknown. So one unknown is A, because once you substitute all these values, you get one unknown. So you found the unknown value of A, which can be found. So once you found the value of the unknown, which is 29.29, please try to get a piece of paper and work on that by yourself, and hope you will get through. So that is the value. So you can find the coordinate of Q, so which is the value. Once you get the value for A, and then you can find the value of Y, which is 8.58. So basically you will be sitting a little bit down there to below the statue. Yeah, and then one thing you should bear in mind, you will get because this is a quadratic equation. So once you solve a quadratic equation, you might be getting two values for A. A is 29.29, which is below here, and A might be the second one you might be getting is the value, I think you'll be getting a value which high, 170.71. You get a point 170.71. A is 170.71 meters, but please note that this is somewhere here. So that means you cannot have the car here at the same time the light reflect, because the light will be going forward, not that the backward. So you need to be a bit careful there. So what is the answer? So you need to select the answer which is below 100 meters. That is where the car will illuminate the statue. Okay, hopefully you will solve this question and see you will get the answer by yourself. Thank you.